When you work with radical equations, you want to arrange the terms so that one radical is isolated on one side of the equation. You're going to then cancel out the radical by raising both sides of the equation to the nth power. If the equation still contains a radical, then you repeat steps 1 and 2 until no radicals remain. You solve for the unknown variable, and then you check your answer analytically or graphically. In number 13, I have 3 times the cube root of 2x minus 7 minus 5 equals 4. So I need to isolate my radical. I'm going to start by adding 5 to both sides. This gives me 3 times the cube root of 2x minus 7 equals 9. I'm going to divide both sides by 3, so the cube root of 2x minus 7 is equal to 3. I raise both sides to the power of 3 because I am trying to get rid of a cube root. When I raise a cube root to the third power, they undo each other because a cube root and a cube are inverses. So this is 2x minus 7 equals 27. I add my 7 to both sides, so 2x is equal to 34, and x is equal to 17. I substitute that back into my original equation. So I have 3 times the cube root of 2 times 17 minus 7 minus 5 has to equal 4. So 2 times 17 is 34, and 34 minus 7 is 27. So I have 3 times the cube root of 27 minus 5 has to be equal to 4. Well, the cube root of 27 is 3. 3 times 3 is 9. And 4 is equal to 4. In number 14, again, I'm going to isolate the radical. So I have negative 2 times the square root of 3 minus x equals 4. And I divide both sides by negative 2. And I have the square root of 3 minus x equals negative 2. Well, again, you ask yourself, with the square root function that doesn't have any transformation to it, it hasn't been reflected, can I be equal to a negative number? And the answer is no, you can't. So again, this is an inconsistent equation, and we say x has no solution. In number 15, I start by isolating my radical. So I have 2 times the fourth root of x minus 8 is equal to 5 minus 9 gives me negative 4. I divide both sides by 2. I have the fourth root of x minus 8 is equal to negative 2. Well, again, a fourth root function is going to behave very similarly to a square root function. It cannot be equal to a negative number. So, again, we have an inconsistent equation, and x has no solution. In number 16, I start by isolating my radical. So I subtract 7, and this gives me negative 6. I divide both sides by 3, and I have the fifth root of x minus 11 equals negative 2. Since the index of my root is odd and not even, like in numbers 15 and 14, I can be equal to a negative. So I'm going to raise both sides of my equation to the fifth power. When I take the fifth root raised to the fifth power, it undoes it. And I have x minus 11 equals negative 2 to the fifth power is negative 32. I add 11, so x is equal to negative 21. I check my answer, so I have 7 plus 3 times the fifth root of negative 21 minus 11 has to be equal to 1. So negative 21 minus 11 is negative 32. So I have 7 plus 3 times the fifth root of negative 32 has to be equal to 1. The fifth root of negative 32 is negative 2. And I have 7 minus 6 equals 1, and 1 is equal to 1. In number 17, I already have an isolated radical, so I'm going to raise both sides of my equation to the second power because I'm working with the square root. My square root is undone by my square, cancels it out, and I'm left with 3x plus 18 equals x squared. I have a quadratic equation, so I have to be equal to 0. So 0 equals x squared minus 3x minus 18. I need two numbers that multiply to give me negative 18 and add to give me negative 3. So I'm going to use 3 and 6, and my 6 is negative. So this is x plus 3 times x minus 6 equals 0. I have x plus 3 equals 0, and x minus 6 equals 0. So x equals negative 3, and x equals 6. But I need to check my answer. So when I put it back into the original equation, I have the square root of 3 times negative 3 plus 18 has to equal negative 3. Well, in this case, a square root will never be equal to a negative. So this is not true. So we say that the x equals negative 3 is an extraneous solution. And when we check the second one, we have the square root of 3 times 6 plus 18 equals 6. So a square root equal to a positive, that's possible. 3 times 6 gives me 18, and 18 and 18 gives me 36. And the square root of 36 is 6. So my only possible solution is x equals 6. Number 18 just takes it up to the next level. When I square both sides of this equation, I am squaring a binomial. When you square a binomial, on this side, my square root and square cancels each other out. I have x plus 3 equals. This is not x squared minus 9. This means x minus 3 times x minus 3. So you have to distribute. So this is x plus 3 equals x squared minus 3x minus 3x plus 9. X plus 3 equals x squared minus 6x plus 9. I have a quadratic, so I want to be equal to 0. So x squared minus 7x plus 6. this factors, and I have x minus 1 times x minus 6 equals 0. So x minus 1 equals 0, and x minus 6 equals 0. So x equals 1, and x equals 6. So we substitute back into the original equation, and I have the square root of 1 plus 3 has to equal 1 minus 3. So the square root of 1 plus 3 has to equal negative 2. Well, this is not possible. So 1 will not work. When I test 6, I have the square root of 6 plus 3 has to be equal to 6 minus 3. So the square root of 9 has to be equal to 3, and 3 is equal to 3. So x equals 6 is my only possible solution. In number 19, I'm going to subtract my x. So this is negative square root of 2x plus 5 equals 5 minus x. When I multiply both sides by a negative, this gives me the square root of 2x plus 5 equals x minus 5. Because what happens here, I'm going to take 5 minus x and multiply it by negative 1. So this is really negative times x minus 5 times negative 1. Those negatives cancel each other out, and I'm left with x minus 5. So now I'm going to square both sides of my equation. I have 2x plus 5 equals x minus 5 times x minus 5. So this is 2x plus 5 equals x squared minus 5x minus 5x plus 25. I have 2x plus 5 equals x squared minus 10x plus 25. I need to be equal to 0. So I have x squared minus 12x plus 20. This factors, and I have x minus 2 times x minus 10 equals 0. So this is x minus 2 equals 0, and x minus 10 equals 0. So x equals 2, and x equals 10. When I substitute those values back in, I have 2 minus the square root of 2 times 2 plus 5 has to equal 5. So this is 2 minus 4 plus 5 is 9. And I have 2 minus 3 equals 5. Well, that's negative 1 equals 5, which is false. So 2 is not going to work. And then I try 10. So I have 10 minus the square root of 2 times 10 plus 5 has to equal 5. So 10 minus the square root of 25. Square root of 25 is 5, and 10 minus 5 is 5, and 5 equals 5. So my only possible solution is 10. In number 20, we have two radicals. So the first step is to get one radical by itself. So I have the square root of x plus 8 is equal to 2 plus the square root of x minus 4. I'm going to square both sides. So this is x plus 8 equals, when I square this, this is 2 plus the square root of x minus 4 times 2 plus the square root of x minus 4. It's a binomial. So I have x plus 8 equals 2 times 2 is 4 plus 2 times the square root of x minus 4 plus 2 times the square root of x minus 4 plus the square root of x minus 4 squared. So this is x plus 8 equals 4 plus 4 times the square root of x minus 4 plus x minus 4. Because the square root squared cancels out. So now I have 4 minus 4 cancels out. And I'm left with x plus 8 equals 4 times the square root of x minus 4 plus x. Well, again, you want to isolate the radical. So I subtract x. That gives me 8 equals 4 times the square root of x minus 4. And when I divide both sides by 4, I have 2 equals the square root of x minus 4. So now I square both sides again. This gives me 4 equals x minus 4 because the square of a square root cancels out. And when I add 4 to both sides, x is equal to 8. So I just check that to make sure it works. I have the square root of 8 plus 8 minus the square root of 8 minus 4 has to equal 2. Well, 8 plus 8 is 16, and 8 minus 4 is 4. The square root of 16 is 4, and the square root of 4 is 2, and 2 is equal to 2.